Let's get right into it. Number 7, superhydrophobic surfaces. When water just doesn't care. You've been told your whole life that water is the universal solvent. It gets everything wet. It's the ultimate social lubricant of the molecular world. But nature said, hold my beer. Enter the lotus leaf. This seemingly innocent plant has leaves so water repellent that water droplets literally form perfect little spheres and roll off like they're late for a meeting. This isn't just kinda water resistant, this is water looking at a surface and going, nah, I'm good. The secret? Microscopic bumps and a waxy coating that trap air so the water never actually touches the leaf. It's like sitting on a bed of nails, but the nails are air and the person is a droplet. Scientists have spent billions trying to replicate this effect for self-cleaning windows, waterproof phones, and jackets that don't get wet, and yet a plant in a pond figured it out millions of years ago. So next time you splash water on your hydrophobic iPhone and it's fine, remember you're basically using a leaf, a really expensive, fragile leaf that needs charging every night. Now, before you go around claiming water doesn't wet things, let's talk about the opposite. Things that absolutely love water. Number 6, the Mpemba effect. Because logic ran out of office hours. Okay, you'd think cold water freezes faster than hot water. That's like saying a short person can drop something closer to the ground than a tall person. Basic physics. But no. In 1963, a Tanzanian student named Erasto Mpemba was making ice cream and noticed that his hot mixture froze faster than his friend's room temperature mixture. His teacher laughed at him, but Mpemba persisted and eventually proved that, under certain conditions, hot water really does freeze faster than cold. This isn't just a kitchen trick, it's a genuine head-scratcher that's been debated for decades. There are multiple competing theories. Maybe hot water evaporates faster, losing volume so less to freeze. Maybe it drives off dissolved gases that usually inhibit freezing. Maybe it sets up stronger convection currents, but none of them fully explain it. Some physicists think it's a statistical artifact, others think it's real but rarely replicable. The point is, even professionals in a Nobel-winning field can't agree on whether a basic fact about ice is true. So if your teacher ever told you to just trust the science, tell them that science is currently fighting over whether hot water freezes faster. And it's been almost 60 years, we still don't know for sure. But I guarantee you one thing, cold water freezes slower than hot water in the court of public opinion. Burn. Number 5. When fire doesn't need a spark. The cold flame. You think you know fire. Heat, oxygen, fuel, boom. But there's a type of combustion that operates in near room temperature conditions and produces almost no visible flame. It's called a cool flame or cold flame, discovered in 1817 by Sir Humphrey Davy. Yes, the same guy who invented the miner's safety lamp. He noticed that a mixture of ether and air could ignite and burn with a dim bluish flame that was barely warm to the touch. You can actually pass your hand through it without getting burned. How? It's a low-temperature oxidation process, around 300 degrees Celsius, 572 degrees Fahrenheit, instead of 1000 degrees C plus, that breaks down fuel molecules slowly. Most of the energy goes into chemical change, not heat, so it burns but doesn't scorch. This is the same process that causes engine knocking in cars or spontaneous combustion in haystacks. It's also involved in the first stage of diesel combustion, and while you might not see a cold flame in your fireplace, it's happening in your car's engine right now. So the next time someone says, fighting fire with fire, suggest they try fighting cold fire with colder fire? Actually don't. Just don't. Number 4. Oobleck. When cornstarch decides to be a rock. Imagine a substance that behaves like a liquid when you pour it, but becomes a solid when you hit it. No, this isn't a bad sci-fi movie plot. It's a simple mixture of cornstarch and water. Oobleck, named after a doctor. Seuss story, is a non-Newtonian fluid, a special category of fluids whose viscosity changes with stress. When you apply force, the cornstarch particles lock together, and the whole thing acts like a solid. But the moment you stop, it flows again. You can literally walk on a pool of Oobleck if you run fast enough or move your feet quickly, but if you stand still, you'll sink. The physics behind it is mind-bending. The particles are suspended in water, but when compressed, they create a temporary solid network. This isn't just a party trick. It's the same principle used in bulletproof vests and some protective gear. So if you've ever been hit in the chest by a cornstarch goo, you'd be happy it turned into a solid. Of course, if it had remained liquid, you'd just be covered in messy goo. And isn't that the real tragedy? Number 3, glass, a 1,000-year-old liquid with commitment issues. You've probably heard the myth, glass in old windows is thicker at the bottom because it flowed like a liquid over centuries. That's actually false. Glass is an amorphous solid, meaning its molecules are arranged like a liquid but locked in place. However, glass is technically a supercooled liquid in the sense that it doesn't have a crystal structure. The reason old windows are thicker at the bottom is because medieval glass blowers couldn't make perfectly flat panes, so they installed them with the thicker side down for stability. But the real mind-bender is that glass does flow, just incredibly slowly, over millions of years. In a lab experiment, a sample of pitch, a glass-like substance, has been dripping 1 drop per decade since 1927. That's right, the longest-running experiment in history shows that pitch flows like a liquid but at a rate that will make you feel like the universe is moving in slow motion. So when you look at a window, you're looking at a liquid that just hasn't had time to drip yet, and you thought your procrastination was bad. Number 2, elephant toothpaste, because chemistry has no chill. Hydrogen peroxide decomposes into water and oxygen. Slowly, like leave it out and it might bubble in a week slow. But add a catalyst, potassium iodide or yeast, and the reaction goes from meh to whoa in seconds. The catalyst reduces the activation energy, allowing the hydrogen peroxide to decompose in a flash, releasing massive amounts of oxygen gas. Mix in some soap, and the oxygen gets trapped in soap bubbles, creating a foamy eruption that can shoot several meters into the air. This is called elephant toothpaste because the foam looks like toothpaste for an elephant. But here's the kicker, the reaction also releases a lot of heat, so if you're not careful, you've got a hot, foamy mess that could burn you. Yet, YouTube is full of people doing this in their backyard with dish soap and 30% hydrogen peroxide, which can cause chemical burns. The FDA has even issued warnings. But does that stop us? No. Because watching a tube of foam spray into the air feels like alchemy. It's a reminder that chemistry can be both beautiful and terrifying, just like my ex. Number 1, sodium, the don't try this at home metal. You've been told to keep away from the periodic table's rowdy children, alkali metals. Lithium, sodium, potassium, these things are so reactive that they'll react with the moisture in the air. But sodium is the star of the show. Drop a piece of sodium into water, and it doesn't just fizz, it explodes. The reaction rips apart water molecules, producing hydrogen gas and so much heat that the hydrogen ignites. But here's the weird part. It's not just a simple chemical explosion. In 2015, scientists discovered that the reaction also involves a sort of Coulomb explosion. The sodium metal ejects electrons so quickly that it forms a temporary metallic plasma that literally detonates. Remember when your teacher said to never put sodium in water? They were right, but perhaps not for the reasons they thought. The reaction is so violent that the sodium jumps out of the water, propelling itself like a tiny meteor. So if you ever see a YouTube video of a chemistry teacher dropping a lump of metal into a fish tank and running away, that's sodium. And if you've ever thought, oh, it can't be that bad, watch one video, then go read a book, preferably from a safe distance. That's all for this video. I will be making similar kind of video in future. Subscribe to stay updated.